Today we're going to be talking about solving one-step equations. And you guys have done this in the past. And this is more of a review/refresher to get you ready for what this chapter is going to be presenting. And to begin today's lesson, we have 3 vocabulary words to refresh our memories about. And to begin, we have the word solve. And so think about what it means when you see the direction to solve. And what it is to find an answer. And we all knew that. Our second definition is inverse operations. And so let's think about what that means. Think about inverse, think about operations, and see if you can come up with a definition. And what they are is they're opposite operations that undo each other. And before we can fully understand what are opposite operations, we first need to make sure that we understand what's an operation. And so if we define operation, we know that it's a math process. But more importantly, if we list examples, we know that operations are adding, subtracting, multiplying, dividing, squaring, and so on. And so inverse operations are figuring out what are the opposites of these that would undo them. And that's what we're going to talk about next. And so if we look at this next slide, we have operations on one side, and then across from that we have our inverse operations, and we have these back and forth arrows. Notice that they have points on both sides. So that means if you start over with our operations on side A, the inverse operation would be on B. But it works both ways. The operation from side B is the inverse of side A. So know that they are very much related. And so our first operation we're going to talk about is addition. The opposite, or the inverse, of addition is subtraction. And then its partner that goes with, if we have the operation of subtraction, its inverse is addition. So notice that these top two are related and just opposites of each other. Continuing forward, our next operation to talk about is multiplication. And so if we know adding is the opposite of subtracting, subtracting is the opposite of adding, multiplying has to be the opposite, or the inverse is division. And if we think about it the other way, if we start with division to undo that, or to take the inverse of division, we will multiply. And notice that those two also go together. Then I added on a couple extras. So I said that one operation is squaring. And to undo a square, what are we going to use? And we kind of talked about this through chapter 1. But if we have a number squared, its inverse is to take the square root of that value. And it actually works both ways then. So then if we have a square root of a value, that inverse would be to square the value. Actually, I screwed up on the first one. And notice how those are written. They would both end up as inverse operations. Ooh, actually, my bad. I was right the first time. We would just square the value, sorry. And notice that those are also inverses. And if you have more questions, we can talk about examples in class, but you're not going to see that for a while. And then we come to my last blank. And this is a special case. And my question for you is, what if we have a fraction? So what if we had A over B? what would we do to take the inverse operation of the fraction? Or what is the inverse of the fraction? I'm going to leave you to try to figure this out on your own because we're going to get to it later. And it's not really an operation. But it is a special case. And so we have a special rule when we work with fractions, and we'll get to that later on. So just kind of leave that blank and we'll get. And now that we've talked about inverse operations, our next step is to just practice. See if we can apply using those inverses. And so if we're going to solve an equation using addition, so because we're using addition, it's an equation with subtraction because it's inverse operation is that addition. And so when we solve equations for an unknown variable, we need to isolate the variable. And you're going to hear me saying that a lot. We got to isolate the variable, get it alone. And so to undo that subtraction right there, what we need to do is use addition. And so when we use that addition, we're going to add that value. So because we want to get b alone, we have minus 3, so we're going to add 3 to both sides of our equation. And then on our right side, we have just that b. But then on our left, we have negative 7 plus 3. Okay, and if we would look on our number line, a lot of us struggled with this. If we would add 3, 1, 2, 3, we would actually get closer to 0. So negative 6, negative 5, we're going to actually be up at negative 4 for our answer. So b equals negative 4. And then our last step, it says to substitute in to check your answer. And so if I erase my number line right over here quick, if we would check our answer, what that means is I'm going to take my equation, negative 7 equals, and then rather than b, I'm going to put in my answer, negative 4 minus 3, and see if this is right. And remember, when you subtract a number, it's the same as adding a negative. And negative 4 plus negative 3, yes it is negative 7. So right there is my check. Now, if I take an example, we're going to solve using subtraction. And so our goal, like before, is isolate variable. So we want to isolate our variable, get it alone. And because we need to get alone this x, we need to get rid of 13. It uses addition, so we're going to undo addition with subtraction. So we have plus 13, we will minus 13 from both sides. In doing so, on the left we have just our variable, and on our right we have 14. So this is my current answer, but I have to check my answer by substituting my value back in. So I asked myself, is 14 plus 13 equal to 27? And yes, it is. Next are you try. So go ahead and try these problems on your own, and then come back to the video and check your answers. Looking at this first example, it's using subtraction, which means that we will use addition to solve. So we have m minus 8 equals negative 14. And what we're going to do is we're going to add 8 to both sides. And on my left I have just my m. And then on my right I have negative 14 plus 8. And remember before when I said on our number line, if we have negative 14 here, when we add 8, we're actually going to go closer to that 0. And so we end up with just the negative 6. I'm going to double check my answer. Is negative 6 minus 8 equal to negative 14? Well, I know negative 6 minus 8 is the same as negative 6 plus a negative 8. And then I add them. They say negative. Yes, it is. My second example, we have 1/2 equals y minus 3/2. So now, even though I have fractions, it's still really okay. We have subtraction, so I'm going to once again use addition to solve. And to do so, I'm going to just add 3/2 to both sides. So I have just y on one side, and now I have 1/2 plus 3/2. Well, this is nice because when you add fractions, you need a common denominator, which we already have. And when I add straight across. 1 plus 3 is 4. But I'm going to simplify it, and I know 4 over 2 is really just 2. So 1/2 plus 3/2 is 2. My current answer, and then if I double check, I would do 1/2 equals 2 minus 3/2. And yes, that is correct.